Hello learners, welcome back to MSD 014 Ecological Economics or Postgraduate Diploma in Sustainability Science. In this session, we are going to learn about economic development, environment, sustainability linkages. In the previous session, we have talked about relation between environment and economic growth, and we have looked into the two basic that hypothesis, that is environment coordinate hypothesis and resource curse hypothesis. When we talk about this environment, the economic development, environment and environment sustainability, we'll find out in contrast to the that's macroeconomics. That in macroeconomics, that is basically preoccupied with growth, and when you talk about, we are trying to understand about economic development, environment sustainability, there is question of understanding new area of ecological economics. In their ecological economics, to understand the relation between economic development and environment sustainability, the challenges is there. The challenges, the basic challenges is the standard emphasis on growth, right? So growth, the word growth, no, it was a panacea in yesterday's, and it has again rapidly becoming today's affliction as well. Growth was a panacea because it was thought to be the solution to macroeconomic problems. That macroeconomic problems of overpopulation, inequitable distribution, and involuntary unemployment and poverty. Again, it is today's affliction because it is leading to overexploitation of natural resources and unprecedented levels of what? Non-degradable waste generation that is damaging the environment. So if the macroeconomy is conceived as part of this system and not the whole system, then the logic of microeconomic optimizing applies to macroeconomics as well. So one would like to know what is the optimal scale beyond which this, what we talk about economic subsistence, should not grow. When your growth becomes uneconomic, then it must stop. So it is the job of ecological economists and environment economists to think about a point when the world reaches the optimal scale, and how do we return if we accidentally pass it. So that's why we need to understand the relation between environment and sustainable development. And when we talk about, in generally, about relation between this environment and development, is understanding the impact of economy on the environment. And this impact that an economy has on the environment, that depend on the number of people, what each person consumes, and technology by means of which goods and services are produced. That's politics theory of IPET, I call the BIT. Now other things, if we take being equal, the impact will increase with population size and the average quantity of goods and services consumed by an individual and the resource intensive technology use. So the IPET identity here is precise way of saying for a particular environmental impact. Here you will see I equal to P into A into T. I stands impact, P is the population, A is the affluence, and T is the technology. So this 3 bar equality sign signifies that this is an identity. I is an extraction from the environment, like oil, coal, timber, or we give waste into the environment, like carbon dioxide in the atmosphere, pollutant, water pollutant, sewage into river, and so on. Then this I impact can be measured in various units also. It can be in terms of tons, liter, cubic feet, depending upon the situation. So it also measures units, leaving the actual units to be defined later in particularly application. P is the, when you talk about the P is measured as number of people. As we know, A stands for affluence, that measure as the economy's total output of goods and services divided by the population, means GDP, right, per capita, GDP per capita. So when we talk about technology, it is measured as units of a particular extraction from or insertion into the environment per dollar of GDP, right. So given this different definition there, you will see in the right hand side of IPT, that IPAT identity is number population into GDP per capita into unit per dollar of GDP. So, if you look into IPAT, is an accounting identity, means I equals to PAT, right? In fact, IPT is a total and it's also very useful. Formula of equation point us to the approximate determinants of the environmental impact on our economic activity. It does not tell us about the fundamental or underlying determinants. If we have two economic with very different levels of carbon dioxide emission, for example, IPAT tell us that they must differ in population size and or in affluence and or in technologies in use. It does not tell us why the economies have different population and or different levels of affluence or different technology. So this IPAT formula cannot tell us what will happen to environmental impact in the future. But it is a useful way to begin thinking about the impact of population technology and important attention to various issues. So this identity, IPAT identity, they use to generate different scenarios which are focused on environmental impact of population growth and increasing affluence. So this brings us to the issues of sustainable development. So sustainable development, as we know, entails doing better now in terms of satisfying the needs and desires of all the world's people while not impairing the resource depletion and environmental damage, the ability to do so in the future. Right. So sustainable development, what it requires? It requires investment in technical change as well as measures to protect the natural environment. So sustainable development involves dealing all these situations of uncertainty, ignorance, irreversible actions of humanity. However, if you look into the interest of this economics and sustainable development, that backs to what we talk about growth models and growth theories of the 60s or 70s, they could not come out with a long-lasting solution. In an influential paper in 1977, one of the economists, John Hartwig, proposed a rule of ensuring non-declining consumption through time, where economy used a non-renewable resource such as oil. It is said that it is possible to have a non-declining consumption as long as the capital stock is maintained by investing the rains from a non-renewable resources extraction in man-made capital. That suggests that man-made capital can be a substitute for natural capital. Further, the rains are those resulting from intertemporally efficient extraction program using sustainability constraints. So this Hartwig's rule, it was criticized on many counts, such as treating environment as a production input, then assuming constant elasticity of substitution and assuming man-made capital as a perfect substitute for natural capital. So, ever since publication of our common future in 1987, that report by World Commission on Environment Development, that report emphasized the importance of both this economic growth for the poor countries and environmental protection to conserve resources for the future. The interest in sustainable development has increased, as we know that. So, after this report resulted in a number of suggestions and operation principles of sustainable development. So, in 1990, there are different number of papers in ecological economics, and one of the ecological economists, Herman Daly, identified some operational principles for sustainable development. Number one, for renewable resources such as fish, forest, etc., all harvest levels should be below the population growth rate of the renewable resources. Point 2, for degradable pollutants, establish assimilative capacities for receiving ecosystem and maintain waste discharge below these levels. There is no rule for cumulative pollutants, hence their discharge should be close to zero. 3, for non-renewable resources, receipts from extraction should be divided into income stream and investment stream. The investment stream it should be invested in the renewable substitutes so that that by the end of the economic extraction, renewable substitute is available. Therefore, the macroeconomic scale has to be controlled. Minimize the matter or energy throughput in the economy. So it is now fairly clear that the emphasis of sustainable development is equity rather than efficiency in the economy. So economic efficiency is relevant to sustainable development is use of less resource per unit of human satisfaction with better technology that will help sustainable development. So efficient use of natural resources improves the prospect of sustainable development, but it does not guarantee the same. So sustainable development is the requirement to our generation to manage the resources in such a way that the quality of life that we ensure ourselves is not denied to the future generation. So equity both in intragenerational, when you talk about intragenerational, it's about across the world, between developed and developing country, rich and poor nation, and the intergenerational, that means between the present generation and future generation, is very much important for sustainable development, right? So that's why recently we have that modeling of different interaction, different scenario of interaction between economy and environment, that is very commonly studied in the area of ecological economics, like common pairing model, which is a very common, very popular. It combines ecological concept of stability with economic efficiency. When you talk about ecological stability, it is prerequisite for the sustainability of the ecological economic system as a whole. So such stability that requires ecosystem resilience means this capacity of the ecosystem to withstand external shocks without losing its self-organization. So protection of ecological sustainability has to be achieved by protecting ecosystem resilience. So economic sustainability is to be achieved by what Hardwood says, while it is not necessary to sacrifice intertemporal efficiency. However, if we look into intertemporal efficiency, it is not a necessary condition for ecological sustainability. So ecological sustainability and ecological resilience is an increasing function of diversity of that system. So natural rate of change of the parameters in the ecosystem with respect to economic activity should be non-positive, right? So the natural parameters, what are those natural parameters? One of the important natural parameters is the rate of net primary production. So the key to the model is incorporation of a couple of constraints that are sufficient for ecological and economic sustainability. So constraints are endogenous in the sense that they are dynamically interdependent, reflecting co-evolution of the overall system. So the objective function is dependent on discounted welfare. You will see in this model, as this model of sustainability, resources available in the economic system at a time include what? Natural capital, man-made capital, and consumer good. X at a time of t, right? That represent the resource availability to the economic system. So the distribution of parameters of ecosystem which make up the natural environment are represented here in Z at the time t, define a probability density function. So at any point of time, the system parameter, that is Zt, are a function of H of the amount of disturbance in the ecosystem. So disturbance is assumed to be equal to the level of economic resources utilization at the time t. So the growth in resource are dependent upon natural growth of that natural growth is that xt, and the economic use of the resource, that is utilization at t. So use itself depend upon the relative prices of pt and economic use resource of ut, so that ut is equal to u dot of pt at time t. Okay. So this basic function of the model is a conventional neoclassical expression showing that over a period of time ending in t, we add up economic benefit Y at the time of T, that which depends on upon the consumption content in that utilization, that is UT utilization, on the natural state of the ecosystem ZT at any point of time. So discounted at R, which is equal to the marginal efficiency of capital plus a term expressing welfare, that is W, in the final period, which depends upon the level of remaining resource XT and also on the system parameter ecosystem, discounted again at the rate of R. So the constraints on the optimization problem are given in the equation of the motion of the ecosystem, the initial level of resource, and the prices and ecological sustainability are constraints. So the condition of ecosystem sustainability is guaranteed by utilization time at equal to 0, null, constant consumption and a constant capital stock over a period of time, which means a 0 rate of economic growth. So finally, an intertemporal deficiency constraint is imposed. So this is Hardwick rule requiring resource rents to be equal to net investment, both evaluated at their socially optimal values. So the result of a sustainable development model should be, number one, along an optimal and yet sustainable path, the marginal benefit for a reduction in the value of all the resources base XT should grow at a rate equal to the discount rate. Number two, ecological sustainability reduces the desirability of economic growth in that along an optimal and sustainable path, any undesirable effects on the ecosystem resilience must be deducted from the pure economic benefits, right? Number three, an intertemporally efficient price path is not necessary or sufficient for ecological sustainability. Such prices in some cases may be compatible with sustainability. However, over the time, changes in the economic resource base have no effect on the real price, so that what is required that U at the time of T equal to 0 or null, that is IGNOU Hardwick rule at time of utilization equal to null, 0. So in this case, we have Delhi, the famous economist. He has referred to a steady state which maintains constants in its matter energy throughput. The steady state economy is viewed as a subsystem in dynamic equilibrium with parent ecosystem or biosphere that sustains it. So this quantitative growth is replaced by qualitative development or improvement as the basic goal. So throughput is the flow of raw material energy from the global ecosystem's sources of low entropy, right? When you talk about low entropy, it is about, example is mines, wells, fisheries, croplands, through the economy, right? And back to the global ecosystem sink for high entropy waste. And it's talk about nature society interaction, right? So ultimately, the changes in U utilization do not impact ecosystem parameter when U is 0. Number 4, to preserve or attain ecological stability, when you talk about preserving or attaining ecological stability means consistent with intertemporal efficiency. In that, we require managing the economic environment interactions in a way which does not interfere with the system resilience, which keeps the system within the natural resilience boundaries. On the other hand, even an intertemporal efficient growth path will not be ecologically sustainable unless if system resilience adversely affected, and there is no economically efficient time path which guarantees system resilience that will be kept intact. Number 5, while solo Hardwick notion of sustainability it allows for sustainability indicators which was value based, such as environmentally adjusted GNP. So holding sustainability, which is adopted by different model, requires a set of physical indicators which measures the resilience of the ecosystem. So since resilience is an increasing function of biodiversity, preserving biodiversity is vital to ecological sustainability. You see how that linkages are coming, right? The ecological economy's approach to sustainability requires that resources be allocated in such a way that they do not threaten the stability of the system or the key components of the system, right? The consumer interest should not be threatened the general system. Then we get welfare of the future generation, the intertemporal equity. So if we summarize the session, that we can summarize in this way, that environmental sustainability gets affected with economic activity, and hence the realization that both are important lead to the concept of sustainable development. And if we look into the earlier economists, what they look at the rate of extraction of natural resources and advocated a steady state where a non-declining consumption and capital stock are maintained over a period of time, from one period to other period. So, and after that, economists had evolved sustainable development model that result in economic efficiency and ecological sustainability, which are jointly interdependent to each other. What we realize is that prices no longer reflect the sustainable level of extraction of natural resources. So economic activity should not disturb the stability and resilience of the ecosystem in the interest of the intergenerational equity. So this is how we have to understand the economic development and environment sustainability interlinkages. Thank you very much.